Hi class. As I mentioned on the last video, that one of the ways that a cloud droplet can grow to a size in which it can fall below the cloud base without evaporating. Basically, what I'm saying is one of the ways in which we can grow a cloud droplet to a raindrop size is through a process called the collision-coalescence method. And so the collision-coalescence method takes place in warm clouds. Warm cloud is defined by a cloud that has a temperature that's greater than -9 degrees Celsius. It is made up of water droplets and supercooled water droplets. And because it's a warm cloud and made up of purely liquid water droplets, it's especially important in the tropical latitudes. Okay, so how do you get different sized droplets and supercooled water droplets in a cloud? Basically, what it boils down to is the size of the condensation nuclei that were available during the condensation process. So the bigger the condensation nuclei, the bigger the cloud droplet is to start with. And again, don't fool yourselves. These are still teeny tiny water droplets. You just have bigger ones that may be 5/100ths of a millimeter in diameter, and many of them will be 1/100th of a millimeter in diameter. Okay, so these bigger water droplets are going to have a greater terminal velocity, and as a result, they're going to fall through the cloud faster. So let's take a look at something like this one right here. So perhaps this cloud droplet is a giant condensation occurred on a giant condensation nuclei, so it starts off bigger. So it has a bigger terminal velocity. The terminal velocity overcomes the updraft, so it starts falling through the cloud. Let's put a guy here. So as it falls through the cloud, it encounters a cloud droplet below it, it collides with it, and it coalesces. In other words, it sticks together. And so it's going to grow a little bit bigger, and as it continues to fall through the cloud, now it encounters another cloud droplet, and it's going to grow bigger. And this continues to happen as this cloud droplet falls through the cloud. So it becomes bigger and bigger and bigger until it reaches the cloud base. And now its terminal velocity is really great. It overcomes the updraft, so it continues to fall through the cloud, up through the cloud base. But now it's big enough where it's not going to evaporate. It's literally going to fall to the Earth's surface as a raindrop without evaporating. Okay? And that's the collision coalescence process. I'm making this video on Monday morning. If you happen to watch it, watch the video today, look for rainfall, which would form through the collision coalescence process. And those raindrops that fall to the surface probably this afternoon are going to be a result of the collision coalescence process. Okay, so the next video I'm going to post has to do with the Bergeron process, and that'll be coming up in a bit.